Welcome to The Explainer. Today, we're diving into a really brilliant plan to tackle two of Europe's biggest strategic challenges with one single powerful idea. Okay, so let's break this down. On one hand, you've got the Iberian Peninsula, Spain and Portugal. They're producing so much solar and wind power that their electricity grid literally just can't handle it all. This leads to massive amounts of perfectly good, clean energy being totally wasted. And get this, in 2024 alone, the price of electricity in that region was zero or even negative for over 700 hours. Just think about that for a second. That adds up to a full month where there was this huge overflow of clean energy that was basically poured down the drain because there was simply nowhere for it to go.
Now, on the flip side of the problem, Europe is dealing with a critical AI infrastructure gap. You see, most of the AI compute power that European companies rely on is hosted in facilities controlled by the US. This creates some huge strategic issues around cost, access, and something called digital sovereignty, which is a big deal, especially with new regulations like the EU AI Act.
So what if you could actually connect these two problems? What if that wasted energy wasn't a liability at all, but was actually the fuel to solve Europe's AI deficit? Well, that's the core question behind this really ingenious concept called the RAIDE Network. The idea is just so elegantly simple. Build a network of 32 data centers right at the source of all that wasted energy, at hydroelectric dams. So by placing these AI data factories right at the power source, you turn what was an economic problem into a high-value strategic asset. The whole network is designed with this really resilient hub-and-spoke architecture. So you have these 32 distributed nodes out at the various dams, and they all feed into one central hub. This design makes the system incredibly robust, but the real secret weapon here is the location of that main hub. And that main hub is located in Sines, a port city on Portugal's Atlantic coast. Now, Sines isn't just any port. It's a unique and really powerful hub of global data connectivity. It's where a bunch of intercontinental submarine fiber optic cables actually come ashore. And this location gives it a massive advantage. I mean, just look at the latency numbers here. Data sent from the RAIDE network through Science can get to New York in about 42 to 46 milliseconds. That is nearly twice as fast as sending it from one of Europe's established data hubs like Frankfurt. This physical advantage just fundamentally changes the game. As the source material puts it, Science becomes a node that competes directly for high-value transatlantic AI workloads. So this isn't just a solution for Europe, it's a globally competitive piece of infrastructure. So the geography makes sense, the tech makes sense, but is it just a clever idea, or is this a real viable business? Let's take a look at the numbers and see if they actually add up. So, this number, this is the crucial point. This is the multiplier. By using that surplus energy for AI computation instead of trying to sell it to an already flooded grid, the network can generate over 23 times more economic value from the exact same megawatt of electricity. It's just a massive upgrade in value. And when you run a full financial model on this, and we're talking about a realistic one with gradual ramp-up periods and all the infrastructure costs baked in, the project looks extremely profitable. For a typical node, we're seeing an internal rate of return around 33%, and it pays for itself in just under 4 years. Of course, any big project like this has risks. So to figure out what could go wrong, the analysis ran 50,000 different simulations. It's a technique called a Monte Carlo analysis to really stress test the business model against pretty much every possibility. And you know what? The main risk was not what you might expect. So, the biggest threat to this project's profitability, it isn't the cost of energy or even finding enough customers. Nope, it's the possibility that the price of the AI hardware itself, the GPUs, could fall faster than expected, which would erode the value of the service over time. But here's the kicker. Even when you account for that primary risk, the simulations came back with a really powerful result. In 84% of the 50,000 possible futures that were tested, the project still pays for itself in under 4 years. I mean, that is a remarkably robust financial profile. Okay, so the individual nodes are clearly viable. But what happens when you build out the entire 32-node network? Well, at full scale, the RAIDE network goes from being a clever business idea to being a truly strategic piece of European infrastructure. Once it's all completed, the network would provide 928 megawatts of IT capacity dedicated entirely to AI. And just to put that into perspective, that is a massive injection of computing power that would significantly boost Europe's sovereign AI capabilities. And at maturity, this network is projected to generate over 6.5 billion euros in annual revenue. It literally turns what was once a source of waste into a major economic engine. And maybe most importantly, it does all of this while being incredibly green. By putting that surplus renewable energy to productive use, the network avoids over 2 million tons of CO2 emissions every single year, compared to using alternatives powered by fossil fuels. So the key takeaway here, really, is that the RAIDE network offers a blueprint for how to turn a regional problem into a global competitive advantage. By intelligently linking up existing assets, the hydroelectric dams and the fiber optic cables, it creates something entirely new: sovereign AI compute at a cost that the conventional market just can't replicate. This whole concept is just a powerful reminder that sometimes the most innovative solutions aren't about inventing something totally from scratch, but about seeing the hidden connections between the pieces we already have. And it really leaves me wondering, what other massive problems out there are hiding their solutions in plain sight?